Our company is EQ Technologic, and we offer a low, no-code data as a service platform which weaves a data fabric. On this platform, there are multiple vertical eCube products like eCube MI, a migration and integration product which builds a digital backbone of connected applications, eCube BI, a business intelligence and analytics product to build KPIs and dashboards, and eCube ADA, an augmented data analytics product which is used to build machine learning pipelines. Here's a list of some of our customers. We start with data access, preparation, and feature selection. We log into eCube MI and see our list of connections for Excel and text files. We also provide over 50 connectors across various enterprise applications, files, databases, and more. eCube MI is used to define an ETL pipeline to process data, and to get it in a form easy for analysis and model building. The defined process uses eCube ADA to perform complex transformations using popular Python data analysis libraries. Here, we load the river flood, coastal flood, temperature, and precipitation data using the formatted file read activity. The results at this stage are added to a staging area for analysis in eCube BI. These results are also joined and staged separately to be used for model building in eCube ADA. The processed individual files are then loaded in BI using the Excel connection. We now perform knowledge discovery, an augmented data discovery feature to analyze the datasets. It automatically identifies relationships in data across different objects and presents them for user review. It also helps discover semantics in data like geographic locations, date series, categories, and more as tags. Data profiles like statistical information about attributes and their distributions is also presented for preliminary data exploration. Once the model is enhanced with the discovery, the Easy Mapper is used to quickly create the cube and begin exploration. The auto-detected joins are leveraged here, and the cube is created in just a few clicks. Once the cube is ready, we can build a dashboard using eCube BI's powerful visualizations and explore the data. The GeoMap shows the number of floods over the last 20 years. Through the line chart, we can observe that cropland exposure to river floods have gone down over the years. Similarly, the built-up area's exposure to coastal floods has also gone down. For Brazil, again, some of the parameters show a downward trend. After exploring the data, we understand that factors such as precipitation and temperature keep changing across countries, whereas indicators related to exposure to flooding show relation with return periods. Thus, we will use that data for our training model. The dataset will be created using pre-processed joined data that was the result of our eCube MI ETL process. We select the required connections and configurations to read data from CSV, specify attribute formats as needed, and create our dataset in eCube ADA. The dataset previews are shown at each step to verify the specified configurations and formats to fetch data. AutoML trials can be created once datasets are defined. With the appropriate pipeline selected, we select the multi-class classification in this case, since we have to predict multiple return periods for river floods. In the second step, we select the dataset we just created to train the model. Here, we can check the distribution of each attribute and override type or skip it altogether as needed. For example, we can skip the identifier columns here. Next, AutoML configurations need to be entered. Since the supported algorithm and number of runs per algorithm are already populated, these can mostly be set to default. We select our target column to predict needs. With metrics that will be reported on our model, such as accuracy, we select the F1 score. Next, we configure our outputs, and we select the feature importance here. We skip the output dataset, since it will just be the predictions of the training data. Lastly, we specify execution-related configurations like log level and when to schedule the run and submit the trial. This should start the trial run. The created trial can be retrieved to see the summary and all its runs. We can retrieve a particular run, which we just created here, to see the details. Here, we see the steps that are executed in the AutoML pipeline and the ones that are still in progress. Once the execution is complete, we can see the Input tab to see the training data summary. The Model tab shows the details of the trained model. The AutoML capability of the tool is leveraged behind the scenes to select the best model and parameters using our selected inputs. The selected model, its parameters, and performance metrics are shown for data scientists to review. Based on the performance, they can decide to deploy the model or rerun the trial with modified inputs for better accuracy. In this case, we see the accuracy can be further improved, and features like country code and date aren't playing much of a role in our predictions. We will rerun the trial by skipping the country code and dates features and modifying the threshold to remove a few outliers in our data. The model now performs better with a good accuracy and F1 score. This model can therefore be deployed as a baseline model. The confusion matrix shows the comparison of correct versus wrong predictions for easy comprehension. The feature importance plot shows the relative importance the model attaches to input features to predict the return periods. Multiple AutoML trial runs can be compared side by side for performance and model parameters, and the best one can be deployed for consumption across the eCube DOS platform. The best performing model metrics are highlighted across runs, so the user can select the appropriate run and deploy the model. Once the model is deployed, it is available for consumption across the eCube DOS platform. We will display this in the eCube BI dashboard. ML configurations are created in eCube BI to apply the trained ML model on the future data in the cube. Analysts can select the model from the available list, view the model metrics, and then map the input columns of the cube to the model. The output prediction columns that the ML model will add are also displayed and can be selected. Here, we select all output columns for the predicted return period and predicted probability for each return period. These prediction columns can be added to any widget in the report and a dashboard can be created. Here, we have created a dashboard based on the deployed ML model for predicting flood return periods. The dashboard shows the predicted average return periods for 2023 and also the geographic distribution of return periods across countries. Now we will see how an analyst can perform a what-if analysis on the model to better understand its behavior. The predicted return period for a country is displayed here. The input parameters like cropland exposure can be changed to see its effect on the predictions to perform what-if scenarios. The predicted return period and probabilities change seamlessly based on the modified inputs. The deployed ML models can have access controls set in eCube ADA. Users and user groups can be added and access rights defined. The deployed ML can also be exported and imported in different contexts supporting model portability. Externally trained ML models in Apache Spark and MLeap formats can also be imported using the same steps, thus extending the model's hosting capability within the eCube DOS platform to external models. Lastly, each request to the deployed ML model for predictions is monitored within eCube ADA. Summary like request status, speed, distributions, etc. are captured for model monitoring and troubleshooting purposes. We have created a few dashboards to answer some possible business questions. This dashboard shows the number of floods by country. Brazil is selected on the geomap, and we can observe that the reason for most of the floods in this country is due to heavy rains, with the maximum number of floods having occurred in the first quarter. They seem to have taken up good mitigation strategies since the population displaced has reduced over the years as seen in the line chart below. As for the US, the maximum number of floods have occurred in quarter 2. The highest cause of floods remains as heavy and torrential rains. We can now take a look at a detailed flood analysis for the US. It is observed that Texas has had the maximum number of floods over the past 5 years, and they have been successful in reducing the damage due to said floods over the last 3 years. Arizona has also reduced the damage and fatalities caused due to floods over the same time period. Once the predictions are presented as part of the BI dashboard for end user consumption, understanding the reasons behind specific predictions becomes paramount. The waterfall chart's model explainability feature tries to explain the predicted probability for a specific country and flood type, and what specific input factors may increase or decrease the model's base probability to predict the final return period. For example, by clicking on Brazil on our geomap, we can see on the waterfall chart that the cropland exposure and land exposure significantly increase the predicted probability for a 10-year return period flood. The end user can then decide to investigate the flood mitigation strategies implemented in the past years for that country. OpenAI-powered narrations are generated and displayed as part of the dashboard to fetch information about flood mitigation strategies. Similarly, for the Netherlands, it's the cropland exposure and build-up area exposure that increases the probability of a 10-year return period flood. We saw 3 products based on the eCube DOS platform, specifically eCubeMI, eCubeBI, and eCubeADA, which were used in data preparation, cleansing, ingestion, in the building of the model, and consuming it for predictions. eCubeMI forms a digital backbone of integrated applications. We have over 80 connectors that connect to multiple enterprise applications. These connectors talk natively to these applications using published APIs, and therefore, it honors the security context and state of each application. We have a unique data virtualization layer built into the platform, which allows the user to mash up the data on the fly and provide the uniform interface and data to the upper layers of the product. eCubeBI is a modern analytics and business intelligence platform which democratizes BI and puts the power of analytics in the hands of the end users. eCubeADA is EQ's advanced analytics product that can discover data patterns, anomalies, predictions, and more using data science and machine learning or DSML techniques. The platform can be used for many solutions such as building digital threads, MBE solutions, enterprise searches, rapidly developing for-purpose apps, application integration and migration, and more. The platform seamlessly helps the user to build low, no-code solutions. Thank you for watching this demonstration of the eCube DOS platform. At EQ, we simply deliver.